Hi everybody, today we'll discuss about the split plot design analysis, especially in randomized complete block design analysis using RStudio. As all of you know that the split plot design widely used for agricultural experimentation, and this design is different from the nested model because of its factors, because in this design the factors are crossed, and in similar way this design is different from the factorial model because of its randomization, and from the split plot design the information is collected from two level or strata. That means from the main plot as well as from the subplot, and each level has its own experimental design. And this type of design, that means from the split plot design, the whole plot or the main plot experimental units serve as blocks at subplot level, and often this design consider split plot design in a two-way. One is split plot may consist of randomized complete block design in whole plot and as well as in the subplot, maybe or completely randomized design in whole plot and randomized complete block design in subplot. So its power is more for subplot treatment factor as well it is interaction. So the following package are required for our uh, analysis, and before that it's better to import sorry my data from the desktop or from my directory. So it's better to import my data. My data name here is SPP in the form of CSV. So I already imported in this way. Yes. Then after we have to check my structure. So let's check my structure of data. As you see, here is the block, and again also the variety, the irrigation, and the yield. So in this design, the variety or the var is considered as a main plot, and the irrigation is considered as the main as a subplot. And while we are checking the structure or the data frame, block, variety, and irrigation are different from factors, so we have to convert into a factor using this function. So type this and submit to your RStudio. Then let's check again whether it is converted or not. So the block, variety, and irrigation are converted from what they are to factor. Then let's create the model. So here is the model, is linear model. GY is the response variable. So here is the block. Then here is the main plot plus the main plot as well as the block interaction plus here is the subplot, that means the irrigation. Again, here is the main plot as well as the subplot interaction. Don't forget that here is the main plot as well as the block interaction, but here is the variety as well as or the factor 1 and factor 2 interact. That means variety and irrigation regime interaction, and you have to indicate your data name. SPPB is our data name. So the difference is here is the variety block is make it differ or make it is split plot design analysis into what split plot randomized complete block design analysis. So you have to expect the interaction of this into our source of variation. So type this and submit to your studio, then type ANOVA and we'll get our result. Yes, as you see here, so as you see here is only the variety as well as the irrigation interval, the irrigation region are significantly affected, but the rest, that means the variety, the irrigation, are not significantly affected the grain yield of wheat. So then after you can also go for mean separation. For our case, the variety is not significantly affected, so we need not to worry about doing this. But however, in case if your data is significantly affected, so you have to use the LSD test is the least significant difference method. Maybe you can change it to Taki or other method. So Y is the model that we created here, the treatment, here is a main plot factor is variety. So type this and submit to your studio. Then let's see the result. So how we in Milka among the two varieties, there is no significant difference for the grain yield. Then still our subplot factor also is not significant. So you can also do in the similar way like the main plot. So you have to change. Here is the irrigation is the subplot factor, or IRR is a subplot factor. So you have to do this way. So type this and submit to our studio. Yes, still there is no significant difference within different irrigation regimes. Here is 20 is A, 60 is A, 100 is A. So there is no statistically significant difference among the irrigation regime on grain yield of wheat. So again, when coming to or when you want to get the interaction effect, so you have to use here is var as well as IR. That means the main plot as well as the subplot factor in this form. And don't forget to include also here is the module that we created before. That means AQ stands for what? This all syntax. So type this and submit to your studio, and also you can furthermore you can get also the statistics. It will give detailed information. So if you want to print, so you have to S2 and submit to your studio. So it will display all relevant information, even also their comparison values, even also their degree of freedom, and etc. So we are just went to the mean separation technique using this significant difference. So we have to observe your mean separation by typing groups. So type this and lastly run. Sorry. So as you see here, the highest grain yield of wheat was observed from Hawi with a combination of 60 millimeter or centimeter of irrigation regime, which is around 120, while the lowest is obtained from Milka at 20 irrigation level. So this is all about split plot using randomized complete block design in our studio. So if you have any question regarding to my tutorial, you can address me through my email wakjara@gmail.com, or alternatively you can provide me through YouTube comment box. Thank you for watching.